Okay. So we finished that. And Regina, define moment of a force. Define the moment of a force. Reggie,
Mr. Ejia.
what's the moment of a force? Maybe Regina is still thinking through it. So let's switch on to Inshira. Inshira, what is the moment of a force?
The moment of a force is the turning effect of the force.
The turning effect produced by a force. Okay,
Okay.
you are
Yes,
right.
please.
Absolutely. It's a turning effect produced by a force. And this is measured by the product of the magnitude of the force and then the perpendicular distance from the point around. Are you writing?
Yes, please.
Oh, shit. Hello. Let me connect my earpiece. It's connected now. So the moment of a force is a turning effect produced by a force, and this is measured by the product of the force and the perpendicular distance from the point of rotation of the body or the pivot to that force. Okay. Now, Trivina, welcome to the class. Trivina, what is a couple?
Please, a couple, it has the same magnitude but opposite direction.
Trivina, I won't try this. I won't try this. Yes, you have the idea, but you are missing key terms. Okay. Gloria, what is a couple? Glory. Where are you there? Oh, okay, Irene. Irene, what is a couple?
Please, a couple is a pair of equal and opposite parallel forces whose lines of action are at a distance apart.
Again.
Please, a pair of
Please,
equal and
hello,
opposite.
Irene, give me a minute. Please, if you haven't unmuted, do so for me. Did I say unmuted? If you haven't muted yourself, do so for me. Okay, Irene, continue.
Please is a pair of equal and opposite parallel forces whose lines of action are at a distance apart.
Okay. Okay. So, Inshira, Regina, when we talk about a couple, if you have a bar and there are two forces, F1, F2, okay, this bar of distance L is pivoted at the midpoint. So this is the pivot. So the point around which the effect takes place. Now, the magnitude of F1 equals the magnitude of F2. but their direction, the direction of F1 and the direction of F2 are oppositely. Okay, an arrangement of this sort, is what we are describing as a couple. So a couple system is when two equal and oppositely directed forces at a common line. There's a common line. The common line. So the two equally but oppositely directed forces act at a common line. Okay, creating that a couple system. You can't say that they act at a common point. If you are talking about a common point, this is it. F1, and then F2 also acts at the same point. Okay, but for a couple system, they act on a common line, creating that couple system. Please, are you okay? Are you okay?
Yes, please.
So, an example of application of a couple steering a wheel. When steering a wheel, when riding a bicycle, okay, when opening opening and closing a bottle, okay, all these applications all under a couple system. And what is the turning effect of a couple? The turning effect of a couple. Yes, Edita, what is the turning effect of a couple?
Please, I haven't done this, so I don't know about it.
Okay, that's no problem. Okay. Patience. I'm patiently waiting for you. Patience, what's the turning effect of a couple?
Please, I don't know.
Oh, okay. Janisha, the turning effect of a couple.
At all.
Talk. Good. So the turning effect. So the turning effect of a couple is known as the talk. Talk. TORQUE. All right. Let's look at the moment question. The moment question and question 4 CII. A uniform beam of length 3 meters has a mass of 6 kilograms. So let me partition the board nicely. So we have a uniform beam. The mass of the uniform beam we are told is 6 kilograms. So mass of beam is equal to 6 kg. Then if a mass of 10 kilograms is attached at one end of the beam, if a mass of 10 kilograms is attached at one end of the beam. Now, class, what are the ends of the beam we have here? How many ends of the beam do we have here? How many ends do we have?
2 ends.
We have 2, right? But listen to the question. If a mass of 10 kilograms is attached at one end of the beam, though we have 2 ends, here they were not specific, okay, with where the mass is attached. All that we were told is that it is attached to one end of the beam. What it means is that you are free to place the 10 kilogram mass at any of the ends. It can be here, can be this end. Please, are we fine?
Yes, please.
Or can you choose to Regina can also decide to Regina is not wrong because the question wasn't specific. Now let's continue. Find where a support has to be placed for the beam to rest horizontally. Find where a support has to be placed for the beam to rest horizontally. So we are looking for where the beam has to be pivoted for it to balance. Okay. Now, we are also given the mass of the beam. But the person said a uniformly beam. When the beam is said to be uniform, what it means is that then the center of gravity, which is the weight of the beam, would act at the center. So said to be uniform is said to be uniform implies that its weight or mass acts at the center. So if it is said to be uniformly, it is said to be a uniform beam, then it implies that its weight or mass would act at the center. So we are given the mass to be 6 kilograms. It being a uniform beam means that the mass or the weight would act from one end to the midpoint would have to be 1.5 cents, where the whole length of the beam to be 3 meters. So its weight would act at this point. Please, are we okay? Patience, are you okay?
Yes, please.
Ishira, where is Gloria? Gloria, are you here? Have you fixed your audio problem?
Yes.
Okay. Now we have to determine where to pivot this to balance. So where do we place what to balance? Let me pick your views. Where do you think what or the pivot would have to be placed for a bar to balance when we have these masses acting around? Yes, give me your views. Where do we place the support to balance it? Yes, if you are ready, please raise up your hand and share with us. Share your view with us. And share, then set the ball rolling. Isha, what do you think the support must be placed to balance the beam?
In between the two forces.
Isha is suggesting that we place the support forces or the weights or masses. So, my audio is giving me. Please let me. Okay. More views. Irene, where do you also think? Where do we place the support to balance this? Irene, don't waste time.
Instead, please between the two force. The
Come
two mass.
again.
Please, between the two masses.
Please let me fix my audio and get back to you. I don't know. It is misbehaving today. Hello.
Mr. Adria.
Irene, go ahead.
Please, between the two masses.
Okay, good. You see, there is no way we can place the pivot here to balance it. Practically, it's like we have a bar and two people are sitting at the sides of the bar, and we have the support over here. Whilst the two people sit here, you want it to balance, be horizontal, straight. Can that possibly be? There's no way it can balance when we bring the support here. So to balance this, the support would have to be placed in between the masses as Ishra suggested. Now, because we are not so specific about where precisely to place the support, let the distance of the support from the end or from the 10 kilogram mass be X. So if from the end to where the support is placed is X, patience, what will be the distance from the 6 kilogram mass, which is the mass of the beam, to the support? Patience, what will be the distance?
Please come again.
If from this end to where the support is X, what then will be the distance from the pivot or the support to where the 6 kilogram mass of the beam is? Well, Patience is engaging her brain. Edita, come in. What then would be the distance from the support to the 6 kg mass? Oh, let's not waste time. Gloria, if this is X, what will be from here to here? Hello? Okay, Edita, go ahead.
Please, I think it should be 1.5 minus X.
Exactly. So if this is X, then this will be 1.5 minus X. Patience, are you okay?
Yes, please.
Okay, so we take the turning effect. The turning effect produced by 10 kilogram, by the turning effect produced by the 6 kilogram. What will this turning effect be? Will it be a clockwise or anti-clockwise movement? This one, clockwise or anti-clockwise? Irene. Hello. Irene, are you there? Oh, shit.
Yes,
Shit. No, let's be quick with our response, okay? Let's be quick with our response. Time. So this will turn in this direction, and this will produce an anti-clockwise movement, and then this will also produce a clockwise movement. The second principle of movement is saying sum of clockwise movements must be equal to the sum of anti-clockwise moments. Fortunately for us, we only have one. So it will be clockwise movement as against or equated to anti-clockwise moment. Okay, moment is force times perpendicular distance. over here, since we can still have it as mass times perpendicular distance, because to convert this to weight, you have to multiply by 10 meter per second squared. But because it's an equation, this is equal to, it is the acceleration due to gravity G would cancel out and it will boil down to the masses. Please, are we okay with what the explanation?
Yes, please.
So instead of going by force times distance, another force times distance, you multiply this by 10 to convert masses into weight. But because it's an equation, gravity will cancel out and it will come back to the masses. So the moment will still be mass times perpendicular distance. Okay, so let's consider the turning effect here. This will be 10 by the perpendicular distance is x is equal to 6 by a perpendicular distance of 1.5 minus x. Please go ahead and find x for me. Calculate for the value of x for me. Are we true? Ishra, what did you get for x?
Please, I'm not done.
Hurry up. Irene, what did you get for x?
Please, I'm almost through.
Janisha, what did you get for x? Trifina, what did you get for x? Okay, go ahead. Just Janisha, go ahead. Janisha, go ahead.
0.6.
So 0.6 centimeter. Oh, sorry, meter. 0.6 meter. Please, let's have a seconder. Somebody to confirm for us. Who else got the same thing? Edita, what did you get?
Please, 0.6.
Good. So it means that to balance this, the support would have to be placed at 0.6 meter from the end where the 10 kilogram mass hangs. That's all. Any question? Any question here? All right. No question. We have talked about the couple system. Now, what is measurement of a physical quantity? Trifina, what do you understand by the term measurement of a physical quantity?
Please, measurement of a physical quantity is the process of determining the value of the quantity using a measuring instrument.
Trifina, you have really tried, but I will not award you full marks. You are giving me the literal meaning of measurement, which is true, but scientifically, you have to add more, okay? Let me pick another view. Inshira, as for Inshira, I will always be taking Inshira from you. Inshira, what do you understand by the term measurement?
Please, I'm going to say a similar thing.
Oh, say it. Say that similar thing.
Measurement is the process of measurement of physical quantity is the process of determining the value using a measuring instrument or yeah, that's all.
Okay. Please let me address somebody's concern. So, Gloria, so what did you get? Or your audio is still not fixed? Oh no. It should be, look at it again. It must be 0.6 meter. Okay. Look at it again. Or let's solve it. Okay, it's right here, so we can confirm. So we have 10x is equal to, what is 6 times 1.5? Class, what is 6 times 1.5?
9.
Pardon?
9.
Oh, I can't hear you.
9.
So 9 minus 6x.
9.
Okay, thank you. So we have 10x plus 6x equals 9. 16x equals 9. Therefore, x is equal to 9 on 16. So Gloria, point 9 on 16 and it should take you there. All right. So measurement of a physical quantity. You see, if I want to measure from here, from this end A to this end B, this interval between the two lines, of course, I'll use a meter rule. Okay, all right. I'll use a meter rule. Okay, what am I doing? This is an unknown quantity. This is an unknown quantity. I will use a known quantity, 1 meter rule, a meter rule, which is same as 100 centimeter. It's a fixed or a standard. Now, as I bring it here, what am I doing? I'm looking at how many more or less, okay, of this unknown quantity, okay, can be obtained from the known quantity. So we define measurement as the process of determining an unknown quantity, okay, by comparing it to a known quantity to determine how many more or less we can make, okay, from the known quantity. So in measurement, we always use what we call as standard. The standard is the known quantity. We compare the known quantity to the unknown quantity and to ascertain how many more or less we can get from the known quantity. So if I measure this and my value is 0.5 meter, what it means is that it is half of the known quantity. Please, I hope you are getting me.
Please, can I repeat the definition?
Okay. Measurement is the process of comparing an unknown quantity to a known quantity, and that is the standard or the unit, to determine how many more or less of the unknown quantity we can possibly obtain from the known quantity. So basically, all that I'm saying is that we compare an unknown quantity to a known quantity to determine how many more or less we can make, okay, from the known quantity, and that is measurement. So in measurement, there is a standard or unit. That's why we say the measurement, that's our unit of length. We say meter. So in measuring length, we always compare it to 1 meter. So if after making the comparison, if assuming you had 0.5, then our conclusion is that we got 0.5 meter, which is half of the known quantity, because 1 meter is 100 centimeter. Okay, so to record 0.5, it means you had half of the known quantity, which is the 1 meter. If you are to measure time, measure maybe from beginning of the day to the beginning of the ending, and obviously the conclusion will be that the time is 24 hours. 24 hours, we can break it down into seconds, meaning if we break 24 hours to seconds, it means that we can get that number of seconds compared to the standard, which is the 1 second. So 1 day is made, please let's convert 24 hours to seconds. After 1 hour is equal to 3,600. So 24 times 3,600 would give us the number of seconds. What is 24 by? Please do this computation for me. 24 by 36. Your feedback delay, please. Let's manage time. 2, 4.
Please, it's
Go ahead.
86,400.
Good. So 86400 seconds. Okay, and the standard or the SI unit for measuring time is the second. What it means is that a whole day, okay, when we compare a whole day to the standard of measuring time, we have 86,400 seconds within a day compared to the standard. Please, are we okay with measurement?
Yes, please.
So in measurement, there's always a known quantity, which is the standard or the unit, and is compared to the unknown quantity to determine how many more or less of the known quantity from the unknown quantity, or from the unknown quantity, okay, to the known quantity. All right. We are to give 2 importance of measurements. Ishra, give me 1. Irene, give me 2. 2 importance of measurement. Ishra.
To avoid cheating.
To avoid cheating. Okay, I'll buy it. Irene, give me 2. Irene.
Mr. Dear,
Your feedback delays.
please. Mr. Dear.
1 importance of measurement. Okay, Janisha.
Mr. Dear,
Janisha, 1 importance of measurement.
To prevent wastage.
Exactly. To prevent wastage. Okay. And to predict. It's for prediction's sake. Okay. It also helps us to predict or plan accurately. Okay. Let's look at